Time now to go all the way back to topic number 2, and we're going to do some review on ratios and proportions. And we're going to start off by just refreshing our memories with some vocabulary here. A rate is a ratio that compares two quantities with different kinds of units. A rate that has a denominator of 1 unit is called a unit rate. So anytime that you set up a fraction and the denominator is a 1, we're going to call that a unit rate. A proportion is an equation stating that two ratios or rates are equal to each other. And what we're going to do in example number 1, we're going to write each rate as a unit rate, and we're going to include our labels. And so the first one here in part A, it says 270 miles on 15 gallons. And our goal here is try to figure out how many miles per gallon we would have with this. Now, you can either set up a ratio table where we would have our miles over our gallons, and then we could fill in our information, 270 miles on 15 gallons. And our goal here is to figure out how many miles with 1 gallon. And so all we would simply have to do, well, we would divide our 15 by 15 to get to the 1 gallon. And so whatever we did with our gallons, we'll do the same thing to our miles, and we're going to divide 270 by 15. And this is going to get us down to 18. Okay, now you don't have to do this as a ratio table. You could also just set up a proportion in order to help you figure this out. What we could do again is miles to gallons, and we're going to set up some rates this time. We knew it was 270 miles on 15 gallons, and that's going to be set equal to, well, something out of 1 gallon. And again, we're just going to show mathematically what we did here. We divided our 15 gallons by 15. And if we did that in our denominator, we'll do the same thing in our numerator, 270 divided by 15. And that gets us to our 18. So either way that you decide to do this, if you like the ratio table method better, or if you like the proportion method better, just make sure that you're setting everything up nicely, include your units, and show mathematically what you're doing to each of your numbers. This is your unit rate right here, and it means 18 miles per gallon. And that slash right there is the word per. All right, we're going to do the same thing in question B. $2.64 for 12 ounces. And in this case, we're looking for how much it's going to cost for every ounce. And so I'm going to go ahead and do the proportion method this time. I'm going to have my $2.64 over my 12 ounces, and I'm going to set that equal to something over 1 ounce. And so in my denominator this time, I'm going to have to divide by 12. 12 divided by 12 is 1, so I'll do the same thing in my numerator. Our $2.64 divided by 12, well, that's going to give us 22 hundredths. And as we now write our unit rate with our units, it's going to be 22 cents per ounce. In question C is 10 miles in 2/3 of an hour. So again, I'll set up my units here. It's miles to hours here. We know that we can go 10 miles in 2/3 of an hour. And once again, we need to figure out how far we could go in 1 hour. This right here is called a complex fraction because it has a fraction within a fraction. The denominator here is a fraction, but our method is going to be the same to evaluate here. We're going to divide our 2/3 by 2/3. Any number divided by itself is 1. So I'm going to have to take my 10 miles and divide that by 2/3 as well. Okay, and if I set this up, 10 divided by 2/3, I put 10 over 1 to make it a fraction. Well, I can just multiply by the reciprocal to help me solve this, times 3/2. That's the reciprocal of 2/3. And when I simplify here, I know that 2 goes into 10 5 times. And so this is going to leave me with 15. And so my unit rate this time is 15 over 1. And the meaning here, well, it's going to be 15 miles per hour, mph. In example 2, we're told that a Hummer went 3 3/4 miles with a half a gallon of gas. And we're trying to figure out how many miles the Hummer can go with 2.5 gallons of gas. And in order to do this, we're going to use our unit rate to help us scale ahead to answer our question. So I'm going to go ahead and set up my problem here. I'm looking at miles to gallons, and I was told that we could go 3 3/4 miles with a half a gallon of gas. And I want to find the unit rate first, how far we would be able to go on with 1 gallon of gas. And so here we're going to have to end up dividing by a half. And so I'm going to do the same thing in my numerator here. I'm going to divide by a half, and I'll let you try and figure out what that's going to come out to be. All right, and so you should have calculated that this is going to give you a unit rate of 7.5 to 1, meaning that it can go 7.5 miles with 1 gallon of gas. Now we're trying to figure out how far it could go with 2.5 gallons. So I'm going to set this equal now to a ratio or a rate where the denominator is my 2.5 gallons of gas, and I'm trying to figure out my mileage. Well, to go from 1 to 2.5, I'm going to have to multiply by 2.5. And so I'll do the same thing here with my numerator. I'm going to multiply 7.5 by 2.5. And when we multiply 7.5 by 2.5, we end up with 18 3/4. And so this means, all right, if we write out our little sentence here, that the Hummer can travel 18 3/4 miles with 2.5 gallons of gas. And so this is a nice example where we practice finding the unit rate and then use that to scale ahead to answer our question. In example 3, we're told that of the 450 cookies that the baker made today, 8/15 of them were chocolate chip and the rest were sugar cookies. So I need to figure out how many of the cookies were sugar cookies. And I'm going to set up a table in this example to help me evaluate this one. And I'm going to actually need 3 different rows here. I'm going to need something for my chocolate chip cookies. I'm going to need a row for my sugar cookies. But then I'm going to need a row for my total number of cookies. And so I'm going to go ahead and set that up. I'm going to have my chocolate chip cookies, and I'm going to have my sugar cookies, and then I'm going to have my total cookies, and I'm going to record in the information that they told us. They told us that 8 out of every 15 cookies is a chocolate chip cookie. So I can put 8 chocolate chip cookies in out of a total 15 cookies, meaning that there must have been 7 that were sugar cookies. And again, your numbers here should add up to 15. 8 and 7 adds up to 15. And now I'm going to add in another column here because I know that there were 450 total cookies. And so I'm going to record that in the total. And now I've got to figure out how I would scale ahead here so that I can answer my question. And so if I think about this, well, if I take my 15 and I would have to multiply that by 30, to get up to 450. 15 times 30 is 450. I'm going to multiply both of these numbers by 30 as well. Well, 8 times 30 gets me to 240. 7 times 30 equals 210. And again, if I just do a quick check, 240 plus 210 is equal to 450. And so now I can answer my question. It said, how many of those cookies were sugar cookies? And we can tell right here that 210 cookies are sugar cookies. In example number 4, they give us the equation y equals 3 5/10 x, and they want to know what the constant of proportionality is. And what we need to recognize is that this equation represents a proportional relationship. All proportional relationships have the same setup in their equation. They're all set up as y equals kx. Okay, I don't have anything else added or subtracted here. It's just y equals k times x. And when we have a proportional relationship here, and this is what our equation looks like, we have something which is called the constant of proportionality, and we represent that with the variable k. And so all we have to do, if I know that this is already a proportional relationship, I just have to look for where k is in my equation. Well, it's y equals k times x, and in our equation it says y equals 3 5/10 times x. So this 3 5/10 must be k, my constant of proportionality. And so I can say here that k has a value of 3 5/10. K equals 3 5/10. Nice example of how we can tell if an equation represents a proportional relationship, but we also have to be able to recognize when a table or a graph represents a proportional relationship. For each table or graph, determine if the relationship is proportional and justify your answer. And if it is proportional, then we're going to state the constant of proportionality k, and we're going to write the equation in the form of y equals k times x. And so in example A, they give us a table here where x is our time in weeks, y is our savings in dollars. And we need to realize here that y is our dependent variable. Our savings, it depends upon how long we've been saving in our time in weeks. And so when we figure out our unit rates here, what we need to do, we have to set these up the same way. We have to set them up as y over x. The value of k is equal to y over x. So we're going to take our dependent variable over our independent variable and see if they all equal the same thing. In our first example, we see that our y value is going to be 40 and our x value is going to be 1. And that's already a unit rate, so I can move on to the next one in the table. My y value is 50 and my x value is 2. And I'm going to set that equal to its unit rate, which again is over 1. Well, I divided by 2, so I'll do the same thing there. I get 25 over 1. And then with my last example here, my y value was 60, my x value was 3. That's going to be equal to a unit rate of 20 over 1. And now I look at my 3 unit rates here, and I notice that they're all different. There is not a constant unit rate, which means that there is not a constant of proportionality. So for k, I'm just going to write NA. There is no constant of proportionality. And since this isn't a proportional relationship, I'm also not going to be able to create my equation, so I'm just going to write NA as well. So that's how we can tell from a table. We set up our unit rates and see if there is a constant unit rate. In part B, if we have a graph, we need to remember that we can tell there's a proportional relationship if we see a straight line passing through the origin. And by looking at this graph here, well, we can tell it's definitely a straight line. And remember that your origin is found at 0, 0, which is right here. And that line does pass through the origin. So I know that this is a proportional relationship. And so we need to figure out what the value of k is. And remember that when we can find our constant of proportionality, it's going to be when our denominator is 1. And that's going to be our x value. So we need to come to the x-axis where x equals 1, which is right here. And we're going to go up until we hit the line. And we hit the line right there. And then we're going to come over and figure out what that is as a y value. And it looks like it's hitting halfway between 10 and 20, which is going to be 15. So k is going to be equal to 15. And so for our equation, y equals kx, well, it's just going to be y equals 15x. In letter C, we again have a table. This time we're looking at dollars per hour. Our dollars depends upon the hours. So we're going to set up our unit rates here, y over x. The first one is 12 over 1, which is already a unit rate. The next one is 24 over 2, which simplifies to 12 over 1. The next one is 36 over 3, which also simplifies down to 12 over 1. And the last one is 48 over 4, which simplifies down to 12 over 1. All of the unit rates are the same, so there's a constant unit rate of 12, so k equals 12. And our equation here is going to say that y equals 12x. That is the equation of this proportional relationship. So again, in a table, look for a constant unit rate, y over x. And in a graph, look for a straight line that passes through the origin. The k value can be found when x is equal to 1. Go up till you hit the line, and then come over and figure out what your y value is. Underneath in part A and B, you're going to have to look at these graphs and tell me if it's a proportional relationship and explain your answer.